Hello everybody! I'm on a little bit early, so if there's any technology things going on, I can fix them early. And I will wait for people to sign on. We have 3 minutes until we start. I'm just getting my notes together. We have 3 people already. I see Amy's here. Hi, Amy! And Ash. Hi, Ash! And Amber. Yay, hello! It turns out that my phone and tablet both don't have the ability to like swap back and forth between looking at me and looking at something else. So I'm going to be using my phone to record and try not to drop my phone as I also use my tablet to show things. So we'll see how that goes. This is the first one that we're doing, so it might be a little bit weird as far as getting technology working, making sure everyone can see things, glare from the window, things like that. So if you see anything that could be improved upon, hey everybody! If you see anything that can be improved upon, please let me know in the comments so that I can improve it for the next one, because I want to have a bunch of these at least once a week. I kind of want to switch back and forth between K through 5 topics and 6 through 12 topics. So the 6 through 12 will be a little bit more math intensive, deal with other engineering concepts like lift and drag, things like that. So, Liz. So if you have a kid in 6th through 12th grade that is watching this, if it seems a little too elementary, it's because it's for elementary school students, but you may also get something out of it, and you can also tune in for the next one, which will be the 6th through 12 grades, and I think I'm going to do that one early next week. So, Ryan, Adam, Carter, Xavier, and Cassidy are all here. Yay! Awesome! It's 4 now. I'm going to wait a little bit longer for some more people to join in. I know we're all trying to learn technology quickly as we telecommute and all of the above, so I'm probably not going to run an hour. It's probably going to be half an hour with both instruction and questions. I mean, we can run a little bit over. It's not like I have anything else that I'm doing, so if you have questions, if you have some space questions for me, and it doesn't necessarily have to relate to the topic that we're doing today, I may not get to all of the questions, but you can type them in now or you can type them in later as you have questions, and I will try and get to some of them. So, yay, we have more people. All right, so I'm going to go ahead and get started. This first topic is on Mars, the planet of Mars, and all of the rovers that we have sent there, and a little bit about how we're exploring Mars and where we might go in the future with Mars. So, first of all, I hope everyone knows that Mars is a planet in our solar system. It's called the Red Planet. Part of the reason we call it the Red Planet is because it has a lot of iron oxide on the surface. That's rust. And so because of that, the planet is red. And you can see it through a telescope, and it looks red. If you have a powerful enough telescope, it has ice at the poles. And we'll talk a little bit about that more later. The first topic I want to get into is the rovers and observation orbiters that we've sent to Mars. And so NASA has been going to Mars since the 1970s. The first ones were orbiters and then landers. We had the Viking landers, Viking 1 and 2, and those sent back the first detailed pictures of the surface of Mars. And then our first rover to Mars, the first one that actually had wheels and like wheeled itself around the surface, was called Sojourner. And I found this adorable website, and I'll send the link out after the video, that describes some of the landers. So look at this little Sojourner lander. They put eyeballs on it. I hope that the words are right side up in this one, facing the correct way. I did a test video and it looked like the words were facing the correct way. I think my camera is adjusting for it, but I apologize if it's backwards. Let me know if it's backwards. So this is the first one. This one was a small one. It had 2 instruments and it was about the size of a large cat. And it had an X-ray spectrometer on it. So what it would do, it would take its little arm and it would put it up to a rock and it would fire particles at the rock, alpha particles at the rock, and then whatever bounced back, visibly bounced back into its spectrometer, would tell it the chemical composition of those rocks. So different chemicals reflect back differently into a spectrometer. And that way it could tell what kinds of chemicals were in the rock without a human actually going and taking a sample of a rock and bringing it back to a lab to analyze. And so Sojourner gave us a lot of information about what kinds of rocks are on Mars. We found out it's a lot of igneous rocks. And so if you know a little bit of geology, igneous rocks are caused by volcanic activity, and we'll get into it in a little bit. There are a lot of volcanoes on Mars. None of them are active, but they were active in the past, and so it spread magma or lava all over the surface of Mars, and so there's a lot of igneous rock. The next rovers that we sent were 2 rovers, actually, Spirit and Opportunity. And here's a little googly-eyed version of Spirit and Opportunity. They looked exactly the same. They were twins, and they went to opposite sides of Mars. And I know someone asked, even before we got started, how much of Mars we've explored. And so I have a little picture here of where Spirit and Opportunity and Sojourner were on Mars. You can see that they were really all over the planet. A lot of them have been near the equator, and usually they wanted to land them in spots that were free of a lot of debris so that they didn't land on debris and break. And they were both about 370 pounds, so you wouldn't be able to lift them. They would be pretty heavy, but they still rolled around Mars on these wheels. And you'll notice that a lot of the rovers look fairly similar as far as the way that they get around. That's because we learned each time that we sent one, we learned what worked, and we just adapted from that at NASA. All right, so the next one that we sent was in August of 2012. So some of you may know this one from maybe the news. This one is the Curiosity rover. And this one was the size of a car. Can you imagine trying to land something the size of a car on Mars? It needed a different landing system because the previous landers were light enough that we could use kind of like squishy balloons on the outside to bounce them across the surface of Mars when they landed. And this one was too heavy to do that, so they used something called a sky crane. And what they did was they had a piece that attached the rover to something that had a bunch of rockets on it, so it could fire at the surface and kind of hover above the surface, and it lowered the Curiosity rover onto the surface with these big cables. And it was a very exciting time. I watched it live, I remember, because they weren't sure, well, they knew it would work, but there was 7 minutes lag between the time that they sent the command to do this and the time that they could get information back as to whether or not it was safely on the surface. And so they called that the 7 minutes of terror. And they anxiously waited for information on whether or not the lander had made it safely onto the surface. And it turns out that it did. And Curiosity has sent back lots of science data. It also has a spectrometer. It has a little scoop, and so it could scoop into the surface of Mars. And it also sent information like wind speed, things like that. And the next rover that we're going to be sending in 2021 is called Perseverance. Let me just scroll over here. There we go. This is the Perseverance rover. You'll notice it looks very similar to the Curiosity rover, but it's going to be building off of what we learned from the Curiosity rover, and it's even bigger. It's like 2,260 pounds. So we're going to be using a similar process. So that's all of the rovers that we have sent to Mars. I see people also have lots of questions. This is great. Yeah. So what did we learn with all of those rovers? We also had orbiters around Mars at the same time. And those are ones that don't actually land on the surface. Those are above Mars in orbit, like we have satellites around Earth. Mars has satellites around Mars, and they take pictures of the surface. They take data on what kinds of minerals and things are in places that we couldn't get to with the rovers, like those deep canyons or the poles. What's there? We found out that Mars has actually more than just volcanic rock on it, and this was very cool. We had thought that maybe there had been water on Mars's surface at some point in the past, and we found with the orbiters that there's not only water ice, a little bit of water ice there now in frozen form. There was also in the past a lot of liquid water on Mars's surface. So 1 billion years ago, Mars may have looked, at least as far as the amount of water, it may have looked similar to things like lakes and small seas and things on Earth. The way that we can tell that is because there's things called silicates, which can only form in the presence of water. We also found, and let me give you the next link here, we also found these cool things. They're called alluvial fans. We have these on Earth, and it looks like this. This is a picture of the ground on Mars. It's a piece of the ground that has kind of a canyon up at the top there. Let me see if I can... This is where having only one hand here doesn't work. Here's my other hand here. Okay, so you can see that there is... There's kind of a channel at the top, and then it spreads out into this triangular area down here at the bottom. That is called an alluvial fan. We have these on Earth. One example is the Mississippi Delta. At the end of the Mississippi River, where it dumps into the Gulf of Mexico, there is an alluvial fan that looks like this. Finding these on Mars means that at some point in its history, there was water on the surface, moving these deposits of minerals and soil around. And so we can use the past, or we can use information about rocks now to determine what it was like in the past. There is also a theory that there's liquid water seasonally on Mars now. And there are videos taken, well, it's not a video, it's a series of still photos that were taken from orbit that show what appears to be water running down a slope on Mars. Now, this isn't drinkable water. You wouldn't want to drink this. It's full of salts. It's more like seawater almost, or like really concentrated seawater like you'd find in the Dead Sea. But you can see that it over a period of a couple of weeks, it runs downhill. And they think that this means that when it gets warm enough to cause the ices on Mars to melt, they may have some salty water or water filled with minerals running down these slopes. All right, so that is some of the geology of Mars. Some other cool facts about Mars. It has a really, really big inactive volcano on the surface. It's called Olympus Mons, which means Mount Olympus. It's not actually Mount Olympus. But it's a huge shield volcano. That's what it looks like from orbit. Huge, giant shield volcano, which means that it's spread out over a large area. It forms what's called a shield. So it's kind of like a big bump on the surface. And it's about the size, I have it written down here, hold on. If it were on Earth, it would cover the entire state of Missouri. It is very big. We don't have volcanoes this big on Earth. And it is over 20 kilometers tall, taller than Mount Everest. And so sometime in the distant past of Mars, when these were active, there was a huge, giant volcano, and it spread a lot of lava over the surface of Mars. Let's see. What other things do I have written down here? Oh, the Mars atmosphere. Okay, so have you ever thought about going to Mars and what it might be like? Well, first of all, you wouldn't be able to breathe the atmosphere. The atmosphere of Mars is mostly carbon dioxide, and it's very, very thin. There is about 100 times more atmosphere on the Earth than there is on Mars. And I have a little picture to show why that is. So Mars used to have a thicker atmosphere. Let's try putting this. We'll put this right here. Oh my goodness. This is one of the things I'll have to work out. Maybe I'll get an easel or something. But so here you have a representation of Earth. And here is the magnetic field around Earth. Have you ever played with magnets? You know how you can have a magnet and you can like pull iron filings in this shape around the magnet? Well, so Earth has a liquid iron core, and it has a magnetic field. Mars, oh my goodness, Mars used to have a magnetic field like Earth when it had a liquid core of iron, just like Earth does. But its iron core solidified billions of years ago, and so it has only small localized magnetic fields, and it doesn't have a worldwide magnetic field like Earth. That means that radiation and high energy particles, instead of going around because they're deflected by the magnetic field, they go directly into the surface of Mars, and it starts stripping off the atmosphere. It takes a long time to get rid of a planet's atmosphere, but it had a long time. And so you have all these energetic particles bombarding the atmosphere of Mars, and it slowly starts getting rid of the atmosphere. So over time, the atmosphere decreases, and now we have an atmosphere on Mars that is very, very thin. It still has wind. That's part of the reason why we have a whole bunch of fine particles of rock on Mars, like a dust that kind of settles all over Mars, is because you have a wind. It also gets worn down, like the moon has dust as well. It gets worn down by the impact of those energetic particles. And it also has the ability to move ice. It can evaporate ice into water vapor in the atmosphere, or I'm sorry, carbon dioxide vapor in the atmosphere, and then redeposit it again as ice as it heats and cools. And so you might have a large patch of ice on the surface that then sublimates into the atmosphere and then becomes ice again later in the year. And so it has seasons. Mars has seasons just like Earth does. There are different seasons. I wouldn't call them, spring. But it does have, times of year where it gets warmer or cooler. The average temperature on Mars is -80. That's an average. It's not always -80. It can vary from -175 Fahrenheit to 70. And so it might be, a very nice, pleasant day on Mars if you had air. So it's a varying thing. All right, so now, before I get to questions, I wanted to show you this cool experiment that you might be able to do in your own house. Parents, you should probably make them do this in the tub or the shower because it's a little messy. I have here, and I'm gonna try and show this, I can't flip the camera, so I'm gonna have to show it like this. All right, so I have here this container full of flour. And you can see that I've already made an impact crater there. You can see the impact crater. It kind of, you can see what the history of the motion of this crater, or I'm sorry, the motion of this meteorite was by looking at the crater. So you can see it slid a little bit, and then it has this raised edge here. So what direction do you think this meteor was coming from? I think it came in this way and then kind of bounced a little bit and ended up there. But you can try this with different, I'm gonna shake it and get it all flat again. You can kind of do this with different sizes of rocks. You can do this with a bouncy ball, whatever you have. So I'm going to try this smaller rock and let's see what the impact looks like. You can try dropping it from different heights. What does it look like if you only build up a little bit of speed by dropping it from a small height versus a lot of speed from dropping it from a big height? What does it do? And so let's try this real quick before I start answering questions. Here we go. All right, I'm going to drop it. All right, what do we got here? Looks like it slid a little bit again, and it's a bit of a smaller crater than if I drop the big one. Let's drop the big one and see what that does. As you can see, there's a lot of mess around it. All right, ready? Oh my goodness. It is a large crater. So, and you can see how many times it bounced. You may not have been able to see it when it dropped, but it bounced 1, 2, 3 times. I guess it bounced twice, and here's the third time. So go ahead and try that at home. You can use flour, you can use sand. I just put it in a Tupperware container. And you can use anything you want to drop in there and record your results. And if you want, share your results here. All right, so that is the end of lesson 1. Let me go through and answer some questions. Wow, there's a lot of questions. I won't be able to answer all of these. I'll answer a few. All right, let's see. Is the moon made of cheese? No. It's made of mostly igneous rock. And some silicates. Oh, okay, so it was a mirrored image. I'll have to flip the text somehow. All right, and I'll send you the website so you can see the text the right way on the website. Ryan wants to know how many robots there have been. Ooh, that is a good question. I know there have been at least 4 rovers. I don't know if there are more rovers from other countries that have been there. There's a lot more landers and orbiters than rovers. It's a lot easier to land something on the surface and just keep it there. And it's a lot easier to put something in orbit around the surface, since in order to get to Mars, you have to put something in orbit anyway. We have a lot of orbiters. If you want to look them up, we have some such as the Mars Reconnaissance Orbiter. We have MAVEN and Mars Global Surveyor. There's a lot of orbiters around Mars from several different countries. Those are just some from the US. Let's see. I'm gonna do like one question from each person unless I get through all of them. Zachary wants to know if Mars has water. Yes, it does. Most of it is ice. It doesn't really have liquid water most of the year, and if it is liquid, then it has a lot of minerals dissolved in it, and so you would not want to drink it. Bruce wants to know, how big is Mars? It is smaller than Earth. I cannot for the life of me remember the actual diameter size difference. I believe it's 1/3 of Earth, but you would want to check that. I can look that up for you, but it is smaller than Earth, and so it has less gravitational pull than Earth. So if you were on Mars, you would be able to jump higher, just like you would be able to jump higher on the moon. It's bigger than the moon, but smaller than Earth. Have they found anything like fossils? No, they have not. So part of the reason we're so interested in water on Mars is because so far we know that all life that we know of needs water in order to survive. And so if we follow the water, we may be able to find life on Mars. It has not been found yet. There have been a lot of false readings. There was one that was I think it was Sojourner that, or no, was it Viking or Sojourner? One of the first ones got a false reading, and they think it was because the reader was contaminated before it even left Earth. And so they read some complex carbonates and thought that maybe that was an indicator of life, but there's really no way to be sure. What we really need are scientists, like human scientists, on Mars so that they can do sample analysis while they're there on Mars. And so that's one of the reasons why we want to send astronauts to Mars eventually, is because they would be more able to go further, dig, in more places, make decisions on the fly about where they want to go, a lot easier than someone on Earth trying to drive a rover across the surface of Mars to go look at various things. So it's possible there's life on Mars. It would be microscopic. It wouldn't, I would really love to find a fish skeleton on Mars, let me tell you, but we think that if there was life, it would be something like little tiny bacteria or algae spores or something like that. Phoenix Mars lander visited the North Pole. Oh, yep, you're right. So we have had landers visit other places, but the rovers have mostly been sort of grouped around the equator. The book movie The Martian shows an astronaut using Martian soil to grow food. Have the rovers found soil that supports that, or was that just based on theories right now? Ooh, this covers two topics that I love. I love plants and I love planets. So let me talk a little bit about what plants need. Mars has some minerals that plants would use in order to grow. They unfortunately also need organic matter in order to grow successfully. And organic matter is basically just dead things. And so Mars doesn't have any organic life to die to form that organic matter that plants would need. They also require some helpful bacteria in the soil. There's little organisms in the soil that help break down nitrogen, and plants need that in order to thrive. So until we could bring those things to Mars, until we could create real soil, we wouldn't be able to grow plants on Mars, at least not very well. They might sprout, but they need more in order to thrive. I think we already answered one from Amber. Renee says, Corey wants to know, how old is Mars? You guys, with the numbers and the hard questions. It is billions of years old. Mars is actually about the same age as Earth and the other rocky planets in the solar system. All of them formed out of the same disk of dust around the sun. And so all of our planets are roughly the same age as far as when they kind of formed into little clumps of matter. Different things have happened to different planets, like Earth, for example, had something big run into it, we think, and form a moon. The planets have shifted positions. Some planets have moved further towards the outside of the solar system since they were formed. But all of the planets are roughly the same age. I just don't know what that age is off the top of my head. Billions of years. Billions and billions of years. Here's one. Hi, my name is Avery. Is Mars the hottest planet? No. Venus has significantly consistently hotter temperatures than Mars. Venus, I can't remember off the top of my head what the exact temperature is, but you can actually melt lead on Venus. It's that hot on the surface. And the one lander that was sent to Venus that sent things back only lasted a couple of minutes, even with all of its shielding. Venus is very, very hot. It has a runaway greenhouse effect. Its atmosphere is very thick, and it holds and traps a lot of heat. And so, as far as planets with atmosphere, Venus is very hot. Mercury is super duper hot. It's very close to the sun, and it's very, very hot on one side and really, really cold on the other side. It has no atmosphere. All the atmosphere has been blown off. If it has any, it might be really, really, really thin, but one side of it is super baked by the sun. And so that is much, much hotter than Mars as well, just because of the proximity to the sun. Oh, thank you. Yes, Mars's diameter is 6,790 kilometers. There you go. There's a number. Slightly more than half the size of the Earth. Oh, okay, all right, so more than a third. A little bit more than half of the size of the Earth. Thank you. All right. We'll do a couple more. How much dust is on Mars? It's a lot of dust. There are solid rocks underneath of the dust, but almost the entire surface of Mars is coated with a dust coating. One interesting thing, we thought that the dust was a lot deeper than it actually is, and less compacted than it actually is in some places. So we sent a lander recently that had a little temperature probe that was supposed to drill into the surface. And we did, I guess I think it was at JPL, they did experiments in sand that we thought was very similar to the dust that would be on the surface of Mars, and drilled into it successfully. But when it went actually to Mars, it couldn't drill down because it was too compacted. And so it was just bouncing out of the hole. They actually are going to try pushing down on it with the little arm, like scooper arm, that's on the lander, in order to get it to actually burrow down into the soil like it's supposed to. Hopefully that works, but there's a lot we don't know. And one of the things that we didn't know was that the sand and dust and such on the surface is actually compacted a little bit further down. Let's see. Any other new questions? Oh, what material is Mars made of? A lot of igneous rock. A lot of iron oxide dust on the surface. Is there iron in the water on Mars? Yes, and it's just everywhere. I mean, there's a lot of iron oxide on the surface, that's why it's red. Hematite is, let me see, I had one here. Ah, yes. Okay, so this is a hematite rock, and it's magnetic. If I stick it to a spoon, here's a spoon, it's magnetic. There's a lot of iron on Mars, and it's in a lot of combinations of other things. There's like iron sulfates that are on the surface. It'll combine chemically with a lot of other things. So not just in the water, but in a lot of things. Is it hot in Mars? I don't know if you meant on Mars or in Mars, so I'll answer both. It's sometimes hot on the surface of Mars. It can get up to, what was it? 70 degrees Fahrenheit. In certain places, in isolated spots where like the sun is shining directly on it, it can get hotter. Inside of Mars, it's not as hot as it is inside of Earth. The iron core has cooled, and so it is solid instead of liquid like it is inside of Earth. Why Mars is red, we went over that. Hi, my name is Anderson. What environment on Earth would be a test model for Mars? Ooh, so we have some places on Earth that we are using as a test model for Mars. One of those places is the Svalbard region, and we take soil samples from that. It's a very frozen tundra type area, and so that's a good model for taking like ice core samples and things like that. We've also done testing in deserts on the Earth. So there's a desert test site that a friend of mine actually got to go to, where they have habitats set up to practice what astronauts might have to live like if they went to Mars. And so they have little habitats, they have to put on a suit when they go outside, they have a little rover car that they drive around the desert and collect samples. And so there's a couple places on Earth that are very similar to Mars, especially geologically. The main difference is that we have life, and we have liquid water, and we have a thick atmosphere, and Mars does not. And last question here. What material is Mars made of, and can we use it on Earth? Mars is made up of very similar materials that you can find on Earth. Earth has volcanoes. Earth has igneous rocks. You can find igneous rocks on Earth. And you can also find carbon dioxide on Earth, for example. Most of the atmosphere on Mars is carbon dioxide. We have carbon dioxide here because we breathe it out. And so a lot of the chemicals that you would find in rocks on Mars can also be found in Earth rocks. Okay, well, that ends today's session. And like I said, I'll post the link to the website that I was looking at before. And I hope you guys have learned a lot. If you want, try the experiment that I did earlier, and I will try and put another one of these up. The next one will be for grades 6 through 12, so it'll be a little bit more intensive. We'll do some equations and things like that. But I will have another K through 5 one up either next week or the week after. So give me your ideas on what you want to look at. We can do black holes, we can do little helicopters, we can do wind tunnels. I mean, I don't know. There's a bunch of things that we work on at NASA, and a lot of them would be very interesting to do. So thank you all, and I will see you next time. Bye.